Dear students, in the last two video lectures, we were discussing about solving a minimization type objective function type linear programming problem using simplex method. So, in the last video lecture, I discussed till the formation of iteration table 1, and this is the slide till where I discussed. In the iteration table 1, I discussed till finding the elements of Cj minus Zj row. So moving ahead with the discussion. Now as you can see, as I've already told you previously also in my previous lectures also, that in minimization of objective function type linear programming problem, for reaching the optimality condition using simplex method, all the elements of Cj minus Zj row should be either positive or 0. But as you can see that here in the iteration table 1, the Cj minus Zj row are not all positive or 0. There is a negative number. So when there is a negative value, this means we have not reached the optimality condition and we need to move to the next step. So the next step is we need to find the most negative value in the row of Cj minus Zj. Now as you can see, the most negative value is minus 2. So minus 2 is the most negative value and we will encircle that column corresponding to minus 2, and that column is known as key column. Now next step is we'll find the ratio. So how to find the ratio? Ratio, as I've already told you, it is the division of the elements of solution column with that of the elements of the key column. So divide the elements of solution column with that of key column, you will get ratio. So here the solution elements are 31 by 3, 76 by 3 and 10 by 3, whereas the key column elements are 5 by 3, minus 22 by 3 and minus 4 by 3. So first element of ratio column is 31 by 3 divided by 5 by 3, and we will get 31 by 5. Now to find the second element of ratio column, again solution element divided by key column element, that is 76 by 3 divided by minus 22 by 3, and we will get minus 38 by 11. Similarly, for the third element of ratio column, it is 10 by 3 divided by minus 4 by 3, and we will get minus 5 by 2. So in this way we have got all the elements of the ratio column. Now next step is to find the least positive value in the ratio column. Now as you can see, there is only one positive value and that is the least one only. So here it is 31 by 5. So in corresponding to 31 by 5, we will encircle the corresponding row, and this row is known as key row. Now where the key column and key row are intersecting, that element is key element. Here it is 5 by 3, and as you can see from here that, as I've already told you in my previous lectures also, that key column is the column corresponding to the entering variable, whereas key row is the row corresponding to leaving variable. So here key row is corresponding to the element corresponding to the basic variable S1. So S1 is the leaving variable, whereas key column is representing the variable x1. So here x1 is the entering variable. So in the next, when we going to make iteration table 2, so there in place of s1 we going to write x1. So S1 is the leaving variable and X1 is the entering variable. So in the next slide, I have shown that how we're going to make the iteration table 2. As you can see, the table remains the same as initial simplex table or iteration table 1. Here also we have the same thing, that CBI, that is cost or coefficient of basic variable, then CJ, that is coefficient of objective function, then BV is basic variable, then solution and ratio. So the basic variable row and the coefficient of objective function, that is CJ row, these two rows will remain same as in the initial simplex table or iteration 1 table. These two rows will remain same. So as you can already see that from the iteration 1 table or initial simplex table, the CJ row has the elements 2, -3, 6, 0, 0, 0. So we have written the same thing here also, 2, -3, 6, 0, 0, 0. And in the basic variable row, we have written x1, x2, x3, s1, s2, s3. So the same thing we're going to write in the iteration table 2 also, that is x1, x2, s3, and then s1, s2, s3. Now next step, we need to fill the basic variable column. As I've already told you, from the iteration table 1, we found s1 to be the leaving variable and x1 to be the entering variable. So in place of s1, we're going to write x1, and in corresponding to x1 in the CBI column, we're going to write 2, because 2 is the coefficient of the x1 variable in the objective function. So we have written the same thing, x1 and its coefficient 2. Now next step, we're going to fill the row corresponding to x1. So as I've already told you in my previous slides also, what is the formula? It is old values divided by key element. So from iteration table 1, I got my key element to be 5/3, and what are the old values? Here the old values are the values of iteration table 1 for iteration table 2. For iteration table 2, old values will be the values of iteration table 1, and corresponding to S1 row, because x1 has come by substituting s1. So for old values, we'll consider the s1 row. So as you can see, the old values are 5/3, 0, 14/3, 1, 0, 1/3, and we're going to divide this row by the key element. So here the key element is 5/3. So we have done the same thing. We have written all the old values first. We have, for your convenience, so that I do not have to go to the previous slide again and again to show you the old values. So I have mentioned the old values in this slide, that is the values corresponding to the row S1 in iteration table 1. They are 5/3, 0, 14/3, 1, 0, 1/3 and 31/3. Now I'll be dividing the old values by the key element. Key element was 5/3 only. So first element of x1 row is 5/3 divided by 5/3, and it is equal to 1. Similarly, second element of x1 row is 0 divided by 5/3, that is 0. Similarly, third element of x1 row is 14/5 divided by the key element, that was 5/3, and that is, sorry, again I am repeating, the third element of x1 row will be old value divided by key element. Old value is 14/3. So 14/3 divided by the key element, here the key element is 5/3. So 14/3 divided by 5/3 will get 14/5. In this way, we will calculate all the values or all the elements of x1 row. So here I've got this, that is 1, 0, 14/5, 3/5, 0, 1/5. Next, I need to find the next two rows of this iteration table 2. I have got one row that is corresponding to x1, and I need to find the next two rows. As I've told you in the iteration table 1, that s1 is the only leaving variable. Rest of the basic variables will remain same. So we're going to write the rest of the basic variables as it is in the iteration table 2 also, that is